Oh, you're still watching? Hey, wake up! Time for part 2. So, if you haven't heard of quarks and leptons, you may still be a little confused how these fit into the larger picture, but we are now going to get away from elementary particles and into composite particles called hadrons, which are made up from quarks and antiquarks and held together by the strong nuclear force. And here it will get more familiar because in this pyramid of baryons, which are made up of 3 quarks or 3 antiquarks, you see in the back right there the neutron and the proton. A proton is made up of 2 up quarks and a down quark. A neutron is made up of 2 down quarks and an up quark. And then an antiproton is made up of antiquarks, so it would be 2 anti-up quarks and an anti-down quark. And same for the anti-neutron, but with 2 anti-down quarks and an anti-up quark. So it's really interesting to see how these fermions build into the hadrons, specifically the baryons, to make up what we know and love as the core of our atom. So as I mentioned earlier, all fermions have a spin of 1/2, and we're going to use this to show the spin of 1/2 for a proton and a neutron, and also we're going to go over the math for the charges. So for the proton, first you take the up quark like that, and you add it like this, and then you add the down quark like this, and then you add the up quark upside down like that, and so you do the negative 1/2 charge, because it will be the opposite way when you have it like that. And that's because you can't have 2 up quarks in the same spot. And then for the neutron, what you do is you do the down quark like this, and the up quark like this, and then you do the other down quark like that, and because it's upside down, then it's a negative 1/2. And so for both of those, the spins add up to 1/2. And then also for the charges, the up quark has a charge of 2/3 and the down quark has a charge of negative 1/3. So you can see that that makes the neutron neutral and the proton positive 1. So just to clarify how to read this pyramid, I put the spins down here, and so there's the negative 1, the negative 1/2, the 0, the 1/2, and the 1. And then over here I put the strangeness, the 0 like that, the negative 1, and the negative 2. And then inside here you can see that I labeled the types of quarks that are being used in each particle. And you can imagine the same thing for the antiquarks, the same pyramid again. Also, I put the little symbol for the particle name. So now we are going to go on to another type of hadron, which is a meson. The 2 types you may hear the most about are pions and kaons. And the pion is represented with the symbol with the little pi. So these 3 are types of pions, and the kaons have the little k. So these 4 are the kaons. Pretty much these are made up of a quark and an antiquark, and an antiquark is represented with a little line above it, like that. So I hope you had fun with the hadrons, the mesons, and the baryons. I think the takeaway is that this is a simplified picture of a concept that probably has more to it than scientists understand. There's parts that are very confusing, like the wave-particle duality, and how these particles fit together with string theory and relativity. But that's good, because that gives us some goals for what to figure out in the future.